You just built a powerful AI application. Perhaps it's an autonomous agentic workflow calling the Claude API 50 times a minute. Back in the day, a standard database query was entirely in your control. Outages were rare. But today, your AI app relies on external third-party language models. So what happens when you hit an LLM rate limit or Anthropic goes down? A 529 overloaded error doesn't just fail a single chat prompt. Your background agents stall. Your database connections back up. The LLM timeout exhausts your thread pool, and a third-party outage just crashed your entire first-party infrastructure. Your first instinct is to add exponential backoff retries. Do not do this. Because LLM queries take seconds to resolve, an agent trapped in a retry loop is a thundering herd that will obliterate your own servers. You don't need a retry loop, you need a circuit breaker. The circuit breaker is a classic distributed systems pattern that protects your app by severing the connection entirely. It operates as a state machine. In the closed state, traffic flows normally to the LLM. If the API failure tally crosses your threshold, the breaker trips open. All subsequent requests are rejected instantly. Zero timeouts, zero locked threads. After a cooldown, it switches to half open, probing the API with a single request. If it succeeds, the circuit closes. If it fails, it stays open. But in AI architecture, an open circuit doesn't mean your app is dead. Instead of dropping the request, the circuit breaker instantly routes the traffic to a fallback mechanism, like a cheaper Gemini endpoint, or an emergent local model running on an edge node. The user might get slightly degraded capability, but your architecture stays online. Stop building glass cannons. Wrap your LLM calls in a state machine using libraries like Resilience4j or PyBreaker. It takes 30 lines of code to prevent a total catastrophe.